Hello, class 11, Aggarwal students. Welcome once again to Math is Possible. We were doing the proving part and I am ready to continue from where I had finished. I had finished till question number 1, part 2 only. 2 parts only I did because these proving I'm doing two-way proving, so they are getting a little long. So let's start with the third part. Question number 1, part 3. The exercise number was exercise number 2B. Okay, this was the exercise. RS Aggarwal students, class 11. RS Aggarwal AGG. Okay, class 11. Okay, class 11 CBSE students. Okay, for CBSE students, even ICSE students can watch. Okay, there's nothing to learn, something extra. Okay, although you will not get these things in your exam. Okay, for ICSE students. So that's for CBSE students. Let's start with the third proving. So these are all proofs. Okay, one of this will definitely come. So I'm going to mark every one of them as important. Okay, so you have to practice all of them if you want to do the proving. A cross B minus C. That's a cross. A cross B minus C is equal to A cross B, okay, minus A cross C. That's what you have to prove. A cross B minus A cross C, A cross B minus. So this is what you have to prove, and definitely you will have to do two-way proving, because for proving you have to do two-way. Those were the theorems. I was just trying to explain what you have to do. Okay, so I proved it only one way. So look at the two-way proving. So this is the part 1 or case 1. Okay, anything write, whatever you want to write. Part 1. Alright, look, let's start. Let A comma B belong to A cross B minus C. Now from here you do implies A belongs to A, okay, and B belongs to B minus C. Look very carefully. From here what have I done? I have simply let this relation, this coordinate belong to a relation, okay, or the coordinate belong to this, okay, that's a relation. Now from here what I have done, I split the first element in the first set and the second one in the second. Now from here A belongs to A, put it in bracket. If you want to put a bracket, put it in bracket, no problem. Okay, and B belongs to B, okay, and B does not belong to C. So what does this minus means? This minus means that this set belongs to B, but this does not belong to C. So now from here what we can write? We can write this. We can write, so A belongs to A and B belongs to B. Alright, A belongs to A and B belongs to B. And this and, if you want you can put a capital. Do whatever you like, okay, and, okay, A belongs to A and B does not belong to C. B does not belong to C. So look over here. From here what have I done? I have taken A belongs to A, this and this B belongs to B. Then this and is written here. A belongs to A and B does not belong to C. Okay. From here what to do? Simply A comma B, okay, belongs to A cross B. Put it in bracket. Okay. And A comma B, I'm looking at the RHS, okay, you have to keep looking at the RHS, belongs to A cross C. Okay, put this inside curly bracket. One more step, okay, of the proving actually. Now from here you can write what? You can write A comma B, they are common, A comma B here, A comma B there, belongs to A cross B. Okay, sorry, over here you have to write does not belong. Alright, otherwise how you put the minus? Okay, does not belong to, okay, does not belong to A cross C. Okay, So what have you done? You have proved this. Now you see, you had started from here, right? And you ended here, right? So what is your next step? Your next step is this. Simple. Implies A cross B minus C is a subset of who? A cross B minus A cross C. That is your next step, and this is actually your part 1. Write it properly, not like me. Okay, write this as P1. That's your part 1. Okay, this is your whole proof. Copy later. I hope you have understood. I am trying to explain once again. A comma B, I have assumed that they belong to this relation. From here, A belongs to this set A, B belongs to the set B minus C. From here, A belongs to the set A and B belongs to the set B, and B does not belong to the set C. From here, this is same for both. A belongs to the set A and B belongs to the set B. Now A belongs to the set A, this and is written here, and B does not belong to the set C. Simple. From here we got a coordinate. A comma B belongs to set A cross B. From here A comma B does not belong to set A cross C. I explained this in the theorem also. You all can check. Now A comma B belongs to A cross B with numbers I have explained. Okay, so you can understand what I have done. So A comma B belongs to A cross B minus A cross C. That means belongs to A cross B but does not belong to A cross C. So now that has become the subset. Now this is your part 2. So in the part 2, what we do, we start with the RHS. See, we started with the LHS in part 1. Now we start with the RHS. So I hope you are getting the basic pattern how I'm trying to prove these things. Okay. Now let's go on to the part 2. Okay. So this is your part 2. You will have to write the whole 2. Okay, like this you can write. Now let's start. Let x comma y belong to A cross B. Now you must be wondering, sir, why are you taking x comma y? Why can't I do A comma B? You can do A comma B. Okay, there is no restriction in that, but just for making it look a little different, because you have already used A comma B. Okay, try and use x comma y. Okay, that will make it look better. That doesn't mean you cannot use A comma B. Okay, you can use A comma B over here also. Implies from here. What does it imply? X belongs to, not x, x comma y belongs to A cross B, okay, minus, put a minus like that, or you can just write the answer, just put this, minus x comma y does not belong to A cross C. Now from here, what can you do? Just change that. You have to change that minus x comma y belongs to, also do one more extra step over here. This is x belongs to A and y belongs to B. Okay, and then write and, alright, x belongs to A and y does not belong to C. Okay, y does not belong to C. Now you can write a small and also. There is no restrictions. Okay, you can go ahead and do what you want. Okay, it won't affect much as long as you are proving it correctly. Now from here, what do you do? Look at this part and look at this part. They are same, right? So what do you have to write? You have to write x belongs to A, alright, and y belongs to B minus C. Look, these are the two parts you are getting now, right? See, y belongs to B but y does not belong to C. So of course y belongs to B minus C. Now from here, what do you get? X comma y, now you have got belongs to A cross, okay, B minus C. So there you go. You had started from here. See, you started from here with the xy. You assumed, and then you ended here. Simple. These two things the same. So now your next step, what to do? Next step is you just have to write that you have started from here. So you have to write A cross B minus A cross C, A cross C, A cross C. Yeah, A cross C. Okay, yeah, is a subset of A minus, sorry, A cross B minus C. Okay, look, we have started from here. B does not belong to C, B minus C. We ended over there. So this is your, what is this? This is your P2. This is your P2. What is your next step? Now you have to write from P1 and P2. So you have finished your proving, okay? Your both way proving is done. Now all you have to do is just write P1 from P1 and P2. Write this from, okay, P1 and P2 we get A cross B minus C is equal to A cross B, okay, minus A cross C. So you have proved this theorem also. Alright. And put it in a box. So, and write approved over there. Of course, you have to write you have proved it in the exam. Don't leave it like that. Make sure you write proved. Okay. And the part 1 and part 2 has given you this answer. Let's go on to the proof of question number 2. The next question is question number 2. Let's prove that also. Okay. So I'm rubbing this off. My next proof is for question number 2. Alright. So let's start with the proof. First of all, let's start writing. Let's write the question again. This is another, okay, important question. Okay, I told you all these proving questions are important. Okay, there are two sets, for two sets actually, for two sets, okay, A and B, of course non-empty sets. For two sets A and B, we have to prove that, okay, prove A cross B intersection B cross C, A cross B intersection, not B cross C, it's B cross A, okay, is equal to A intersection B cross B intersection A. So you get two-way proving, of course, you have to do over here. So let's start with the proof. So how do you start? Same way, write 1 and write part 1, okay, part 1. So this is your part 1 and start. Let A comma B belong to, alright, A cross B intersection, okay, B cross A, alright, let them belong to this. Now from here what can you write? Which implies that A comma B belongs to the relation A cross B, okay, and it also belongs, or you can just start with that intersection, A comma B also belongs to the relation B cross A, okay, that's a curly bracket. Here you go. Next, from here what can you write? Then you can write A belongs to A, okay, and B belongs to B. Put it in a curly bracket and write and, okay, just to differentiate, and A belongs to B, okay, and B belongs to A. So now you can see what belongs to what. What is happening? You can see that A belongs to A and A belongs to A. A belongs to B. B belongs to B and B belongs to A. Just shift these two positions. Okay. So now what do you have? Now you have A belongs to A. Okay. And A belongs to B. Then you have and. Okay. From here what do you have? You have you have B belongs to B and B belongs to A. Alright, now things have changed. Why? Because now same element. That means this A belongs to A intersection B. This and changed to intersection. Okay. And that and has changed to a cross. Put this in a curly bracket. Put this, right? And only. Okay. And B belongs to B intersection A. So now you are done with it. Okay, now you have the coordinate type. Okay, now you can write A comma B belongs to A intersection B cross B intersection A, and that is what you had to prove. That's not what you had to prove. This is your last step. So you see, you start from here, right? You all start from here and we end it over here. So these two are the same things. From here we have got our part 1. So what is our part 1? You have to write A cross B intersection. Okay, B cross A is a subset. Is a subset of, what is it? A intersection B cross B intersection A. So that is your next step. That's your part 1, I mean. Sorry. So you can write this as part 1. Write it as part 1. So this is your P1. Okay. Now we'll go to the next proving. Okay, the next way, I mean part 2. From part 1 and part 2 only we can say that they are equal to each other. Not only from part 1. Okay. You cannot do one-way proving. You have to do two-way proving. So let's go on to the part 2. Okay. So next we'll start with the RHS, correct? So let's start with the RHS. Okay. So this is my part 2, right? 2, right? 2 here. Then write let what x comma y belong to A intersection B cross, okay, B intersection A. Look very carefully. What have we done? We have taken a relation x comma y now. Okay, not repeating the same, which implies that x belongs to, okay, A intersection B, alright, and, okay, and put this in curly bracket, and y belongs to B intersection. I'm so sorry, excuse me. Now from here what do we do? From here, this x belongs to A, okay, belongs to, sorry, and x belongs to B. From here you split it, x belongs to A and x belongs to B. Then from here again you write this as and, same thing, y belongs to B and y belongs to A. Now you have to write this in the coordinate form. Okay, now but you cannot write that because you have to change positions. Now take this there, bring this here, same thing do. Okay, bring this here. Now x belongs to A and y belongs to B. Okay, and x belongs to B and y belongs to A. Now you got it in the coordinate form back again. So now from here x comma y belongs to A cross B. This is one part. Okay, then write this and as it is. Write x comma y belongs to B cross A. We have started from here. We are getting the LHS. So these are the two parts I split it into. Now from here what do you do? Now from here very simple. Okay, let's use this new marker. I can't wait to. Okay, now from here next step is what? Just take x comma y out and write belongs to A cross B, alright, intersection B cross A. Not very easy, not very difficult actually. So there you go, that's done. From here one more step is left. I'm writing it there. So that is just to see you have got the same thing, right? What happened to me? Do I have a cold or what? Corona. From here, you see this part and this part is same. So one more last step is left. That means you start from here. So you can write A intersection B cross B intersection A is a subset. You write normally in your book. Okay. I don't have space. A cross B intersection B cross A. See, proved it. Okay, y belongs to, all correctly done. X belongs to, y belongs to, A cross B and B cross A. All done.
All correct. So this is your P2. Everybody, this is your P2.
Now next step is what to do. Just write from P1 and P2. You have to write that they are equal. So let's start with that. From P1 and P2, you just have to write that it's done. Question is done. So from P1 and P2, from P1 and P2, you can write this, that A cross B, okay, intersection B cross A is equal to A intersection B cross B intersection A. Alright, that's it. Let's leave it 2 proofs every day, because every video, because I don't want to stress you. Okay, so these are the 2 easy proofs actually, I would say. In the next class we'll do the next proofs. Okay, there are many more, like 3, 4, 2 parts are there, 5 is there. Okay, 5 till question number 5 only, it's all proving. Next we just have to find the answers. Okay, that's it for today. We shall continue in the next video. Take as much help as possible from my and your channel, Math is Possible. See you.